Today, we are going to talk about dividing fractions. If you need to know, this is chapter 4. I'm actually going to combine lessons 6 and 7 because they're very similar. One of the things we need to talk about before we actually get into dividing is this concept of a reciprocal. Some math teacher somewhere coined the phrase the fliprical, and some people like it and some people don't. So if you've heard it, it's another nickname, a cutesy name for the word reciprocal. What is a reciprocal? It's when the numerator and the denominator switch places. And I'll show you an example in just a second. Fun fact, when a number is multiplied by its reciprocal, the answer will always be 1. That's the mathematical way you can test if two numbers are in fact reciprocals of each other. All right, so let's look at some examples here. If I have the fraction 3/4 and these two numbers were to switch places, I would end up with the fraction 4/3 as a reciprocal. Now you have to be careful with your notation here. I am not going to put an equal sign between them because 3/4 is less than 1 and 4/3 is greater than 1. So they are not equal fractions, but they are kind of related. So I'll put an arrow in between them. All right, let's look at this one, our improper fraction here. If I was to use the reciprocal or flip 8/7, I would get what? That's right, 7/8. All right, how about our whole number 4? It's kind of hard to flip when there's only one number. What should be in the denominator spot? It's really there. It's just hiding. It should be a 1. So when I go to flip that, 4 turns into 1/4. And my last example is 9 2/5. What do you think the reciprocal of that is? I'll give you a hint. It's a trick question. There isn't a reciprocal for 9 2/5 as it's written. I would first have to change it to an improper fraction. 9 times 5 is 45, plus 2 is 47. Then I could flip from improper form. Notice my notation. These two are equal. 9 2/5 does equal 47/5. But 47/5 does not equal 5/47. Those are the flips. So sometimes you'll still use the equal sign when they truly do equal each other. And sometimes you'll use another notation to show that they're related. All right, so that is reciprocal. Let's use the reciprocal. I gotta tell you, I'm not a big fan of division. It's always kind of hurt my head. So when I found out there was a way to not have to do division and do multiplication instead, I was all about that. Dividing is the same as multiplying by the reciprocal, right? Dividing, multiply by the reciprocal. You have to do two changes. I switch dividing to multiply, and I switch the fraction to its reciprocal. All right, so let's look at this. If I have 1/2 divided by 1/3, to set this up, the first fraction stays exactly the same. I'm going to change the division to multiplication. And then I'm going to use the reciprocal for the second fraction only. So if you've ever heard the saying, keep, change, flip, that's exactly what I did. Some people hate that and it's confusing. Some people love it because it helps them remember. Okay? The first number stays. We change to multiplication, and the second number flips. Then it's like multiplying the fractions like we've been doing for a couple days. So I'll go straight across. 1 times 3 is 3. 2 times 1 is 2. That is my answer. It cannot be simplified, and I don't have to switch it to a mixed number. And actually, for what you're going to do today, I'm going to ask you to keep them in this form. All right, let's try another one. Here I have 5/7 divided by 10. Well, it doesn't have a denominator, so let me add one. Okay, now it's 10/1. So I'm going to do the same steps. I'm going to keep the first number exactly as it is. I'm going to change to multiplication, and then I'm going to use the reciprocal on the second number. Keep, change, flip. Then I multiply across. 5 times 1 is 5. 7 times 10 is 70. This is not in simplest form as it stands right now. It's correct, but it's not in simplest form. So let's see. Are they both even? No, can't divide by 2. Do they both end in 5 and 0? Yeah, they do. So let's divide by 5, if my pen wants to work. 5 divided by 5 will give me 1. 70 divided by 5, I'll do a little division over here on the side, and I get 14. Final answer of 1 over 14. So 5/70ths is not wrong, it's just not done. You had another step to get it to simplest form. All right, and then one more. This time the whole number comes first. So it still needs a denominator. The problem reads 2 over 1 divided by 3/5. Nothing changes. We still do keep the first number. We still do change to multiplication. And we still do use the reciprocal. Now I'm going to multiply straight across. 2 times 5 is 10. 1 times 3 is 3. I cannot simplify that, so I'll leave it as 10/3. All right? It doesn't matter what is in the first position, that will always remain. And it doesn't matter what's in the second position, that will always remain. Now you'll notice these were only fractions and whole numbers. We had no mixed numbers. That will come in the next lesson in the chapter.